Okay, we're going to talk about trigonometry today. More right triangle stuff. So right triangles, you know, if you have two sides, you can find the third side with the Pythagorean theorem. Okay, I'm not going to write the whole thing. And that's what you use to find the third side. Okay, so if you're given two sides with trig, you can actually find two angles. It gives you that ability. Okay? A side and angle, if you're given a side and an angle, you can find the other two sides. Okay? All right, so to do these three formulas, you need to understand opposite, adjacent, and you already understand the hypotenuse, right? Okay, because that's how you create these three formulas. All right, so everything's about perspective, okay? So if we want to find angle A, this angle, then we need to know which numbers or sides are opposite, adjacent, or hypotenuse, so I can use these formulas up here, okay? So from this angle A, opposite is all the way on the other side, okay? So this is the opposite side, okay? So that's the opposite side because it's far away. It's like going across the street, okay? Here, adjacent's next door, okay? It's real close, but it's not the hypotenuse because we know that's the hypotenuse, right? We don't even have to think about that. That's the hypotenuse because it's across from the right angle. Okay, but adjacent is next to the angle, it's adjacent to it, and it's not the hypotenuse. Okay, so this is the adjacent side. Okay, now what if you're talking about from this perspective? Okay, so if you're talking about for angle B, then opposite would be way over here on the other side. This would be opposite for angle B, and then, you know, this is the hypotenuse. And then here, for this angle, that's the adjacent one. It's next to it, but it's not the hypotenuse. So it's adjacent. All right? So we're going to be using these three formulas. Okay? Sine of A. This is a angle. These are angles. I'm not going to write them on all of them, but that's what those are supposed to be. So sine of the angle is equal to opposite over hypotenuse. Cosine of the angle is equal to adjacent over hypotenuse, and tangent of the angle is equal to opposite over adjacent, okay? And they write it like this, short, you know, opposite OPP, opposite hypotenuse. Cosine, adjacent over hypotenuse, tangent, opposite over adjacent, okay? And they have, you know, throughout history have come up with different ways to try to remember this. They used to call him an Indian chief, SOHOTOA. In the 60s, they had this saying, which is really bad, but I'll say it. Some old hippie caught another hippie tripping on acid, okay? Yeah, it's dumb, sorry. Anyway, but sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent. That's these three formulas, okay? So, for angle A, okay, so I'm looking at it from this perspective. I want the opposite over hypotenuse because I'm trying to find sine. Okay, so opposite would be 3, right? And then the hypotenuse is, of course, the 5. So this is 3/5. I just did opposite over hypotenuse, right? It's like that's the fraction that I'm trying to create. So I could use sine of A. Now, if I want to use cosine of A, that's adjacent over hypotenuse, right? So adjacent's next to it, and you know that's the hypotenuse, so 4/5. Okay? And then tangent of A, tangent would be opposite, right? Opposite over adjacent would be opposite over adjacent, right? Don't even use hypotenuse, right? So opposite over adjacent is 3/4. Okay, now we're looking from the perspective of angle B. We want to find sine B. Okay, opposite over hypotenuse. So opposite of this angle would be way over here, 4. And then hypotenuse is here. Opposite over hypotenuse, right? 4/5. Don't have much room there. Okay, cosine is adjacent over hypotenuse, right? So I'm going to go adjacent, which is 3, over hypotenuse, 3/5. Okay? And then tangent is opposite over adjacent. Opposite over adjacent, 4/3. Okay? And all of it will make sense later. Okay, so to use your calculator or Desmos, you have to be in degree mode. All right? So let me get my calculator here. You have to be in degree mode. All right, there's a mode key right here, right next to the second key. So you have to be in degree mode. Okay, mine is already in degree mode. Usually you get it and this thing's selected and it's in radian mode, but we want it in degree mode. So you scoot over to degree and you've highlighted it, but you have to hit enter to select it. And then you can just clear and get done. So now you're in the right mode, okay? So if you want to do tan 15, it's going to give you this decimal that's 4 long, or you want it to be 4 long. Anyway, so tan 15 is 0.2679. 0.2679. Back in the days of no calculator, you had big giant lists that you'd have to go find 0.2679 and then you'd find your 15. Anyway, now we got calculators. All right, tan of 89. Tan 89, enter, is 57.28. No, it's, with those 99 and 6, you'd have to go 2900. Wow. Okay, tan of 30. Tan of 30 is 0.5774. 0.5774. And then tan of 60 is 1.7321. 1.7321. Okay, so now we're going to find the missing angle. Ding, 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 ding. Whenever you find the missing angle, you're going to use the inverse tangent, okay? That's when it has that -1 on it, okay? So we're going to do inverse tangent. And whenever you find this, you're finding an angle, so just to the nearest degree is good, okay? So if we want to find inverse tangent and we've got 1/2 for a fraction, then we go like this. We say second tangent. See where that inverse tan is right there? Can you see that, what I'm pointing at? Right above the tan key is tan -1. So I have to use second to get to it, okay? So tan -1 of 1/2. 1 divided by 2, and I get 26.56. Like I said, 27 degrees. Whole numbers for angles, okay? Just do whole numbers for angles. And then tan -1 of 4/3, second tangent 4 divided by 3 is 53 degrees, okay? Second tangent 7 divided by 2 is 74 degrees, okay? We're finding an angle. Ding, 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 ding. Whenever you find an angle, use inverse tangent, okay? Oops, that's wrong. All right, so inverse tan of 1. Second tangent 1 happens to be 45 degrees. Okay, now here's where we really start doing problems, okay? The first type of problem we're going to do is x on top. This is actually, you've seen this already. Today, and today we're just going to talk about tangent, okay? I'm going to get you, used to this stuff before we move on to doing all three at the same time. Sine, cosine, and tangent. You have to decide which one you're going to use every time. Like you look at the angle and you say, that's opposite over adjacent. Well, opposite over adjacent, that's tangent. We're going to do tangent. But today, all of them are going to be tangent, okay? So you can get used to it. But next time you'd be trying to, this 20 could be over here and it'd be opposite over a hypotenuse, which is sine, but today is tangent only. This is the formula of your equation, okay? A is your angle. So you say tan of 24 degrees, okay? And then you got to create your fraction. So opposite is way over here. That's the opposite side, right? And this is the adjacent side, okay? So opposite over adjacent is x over 20. So you're plugging into this formula. You've already plugged a 24 in here. Now you're going to put an x here and a 20 on bottom, okay? The opposite one goes on top, which is x, and then 20 goes on bottom. It's the adjacent one, okay? All right, so now you've got your formula, and whenever you have x on top, you multiply, okay? It's really cross-multiplying, like if you had a 1 down here, 1 times x is x, okay? But really, these two are going to be multiplied together. Big, very important thing, 20 has to go in front. If you don't put 20 in front, like this, it'll be wrong. Because if you put it in back and times the 24 times 20, then you'll just change the angle size. So this is 20 times tan 24, okay? And that'll be the length of your side. So all you got to do is punch it in. So you got a 20 tan 24, is that right? Yeah, okay, and that's 8.9, all right? So x is 8.9. So we just found out how long this side is, okay? by plugging in the angle, the x for the opposite and 20 for the adjacent, okay? And we worked it out. Whenever x is on top, you multiply, right? And the 20 has to go in front, and then you multiply and you get your 8.9. All right, same problem over here. Okay, I'm gonna scoot this over. And we'll go like this, okay? Tangent of 56, I know it's tangent because it's opposite over adjacent, okay? Opposite is x on top again. Here's another x on top problem. So basically these multiply together. 3 goes in front of tan 56. You punch it into the calculator, and x is, you know, whatever that is, okay? So we go 3, can y'all see? Yeah, 3 tan 56, hit enter, and you get 4.4. Whenever I'm finding sides, I do tenths. Okay, so this side was 4.4 long from here to here. Okay, easy enough. X on top, you multiply. Okay, X on bottom. There's 3 types. X on top, X on bottom. Ding, 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 finding an angle. Okay, so X on bottom. You'll see how that works because we're doing tan, like I told you, all day long. So this is 35, so that's opposite over adjacent. You know, you got your opposite over here and your adjacent here. So opposite over adjacent, you got tan 35 is equal to opposite, which is 10, and then adjacent, which is x, okay? X is on bottom, right? Now you have to do something different here. You switch them, okay? You switch, okay? You switch and then you divide, okay? And so I'm going to put this one, I'm going to switch these two, okay? So x is going to be on top over here, and then 10 stays where it is, and then the tan 35 is going to go on bottom. Now that seems weird, huh? Well, I mean, look at this. If I had x over 10 is equal to 12 and 6, whatever. If I switch the 12 and the 10, is that going to change the value? Because you're just multiplying. 10 times 12 is 120. 12 times 10 is 120. Doesn't matter. So I can switch them if I want to, okay? So I need to solve for x anyway, so I need to get it off the bottom. So I'm moving it over here, okay? So you switch and then you divide. Don't forget to divide whenever you do this, okay? So let me scoot this over so you can see, make sure you're seeing everything. Okay, 10 divided by, don't forget the divide by, everybody seems to forget that part. And then you say tan 35 and hit enter. And that's 14.3. 14.3. That's how long this side is, 14.3. Okay, X on bottom, switch and divide. Same here, X on bottom again. Okay, this is opposite, and this is the adjacent, so this is tangent, right? So we say tan of 65 is equal to 50, which is the opposite one, over the x. So what do? Switch and divide. So you switch them, and the x goes back on top, and the tan 65 goes on bottom over here, and then you got your 50 still in the same place, and then you just divide. Switch and divide. So 50 divided by, don't forget that part, tan 65, and you get 23.3. So x is equal to 23.3, which is the length of that side right there, okay? So x on bottom, switch and divide. Angles, ding, 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 what do? Inverse tangent, okay? I should write that up here. Inverse tangent, okay? Or just say -1. It's redundant to do it twice. Okay, so what you're going to do is just do inverse tangent, okay? Inverse tangent of whatever fraction. So from here, that's opposite. This is the adjacent, right? So opposite over adjacent is 8 over 5. And so you do inverse tangent, okay? I don't think you can see everything. There we go. Okay, so inverse tangent, so second tangent, 8 divided by 5, gives you the angle. Okay, whenever I talked about angles, we did to the nearest degree. So this is 58 degrees. Okay, so the measure, like y, okay, it says y here, so you probably should have a y there on this one. But anyway, I'll show you this, but it's probably just going to be confusing. Okay, tan of y, okay, is equal to opposite over adjacent, right? So the way they ended up solving this problem for y the angle, okay, is that they multiplied both sides by tan negative 1. Okay, tan negative 1. So I'm going to go ahead and put the numbers in here. 8 over 5. Okay, so tan negative 1, you remember negative 1, if you want to change it to a positive 1, it has to go to the bottom. So this is now on bottom, but it's positive now. Okay, and so these two tans, it's kind of like tan over tan is 1, right? So you can cancel them, and this is y degrees, the measure, like this is the measure of angle y, is equal to tan negative 1, right? 8/5. Okay, so they multiplied both sides by inverse tangent is how they solved it. But I just needed to show you that because y'all are pre-AP GT students. You need to know it, okay? But in general, ding, 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 just do inverse tangent 8 over 5, okay? And get 58 degrees. Here, same thing, inverse tangent, ding, 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 it's an angle problem. All right, so you put which one on top? Yeah, this is the opposite, this is the adjacent, so you put the opposite on top, so that's 5 over 12. So inverse tan, second tangent, 5 divided by 12 is 23 degrees. 23 degrees for the measure of angle, it looks like a nose. Anyway, y, okay? It's 23 degrees. Sometimes they'll have the outside letter be A, and they'll say the measure of angle A. And they won't even have the angle in there, okay? They'll ask for the measure of angle A. It's 23 degrees. Anyway, whatever. Different ways they can ask problems. Okay, so this last one here, the y is way up here. So whenever you do inverse tangent on this one, make sure that you put the 12 on top because that's the opposite one, over 5. So this is the opposite, this is the adjacent, right? So 12 over 5. So you punch it into the calculator. And let me see. Second tangent, 12 divided by 5. And you get 67 degrees. Equals 67 degrees. Okay? So that's about it right there. Have a good day.